All right, ladies and gentlemen, welcome back to another Algebra 1 lesson. Hopefully, you had a great Christmas break. Let's go ahead and get back to the grind, though. Today we're going over an introductory lesson of geometric transformations. The two transformations that we're going over today are translations and dilations. Now, a translation is typically described as a slide of a geometric figure from one position to the next, and a dilation is usually described as a growth or a shrink based off of the starting and ending image. Now, we do have certain ways to describe the starting and ending image, and that's based off of the points that we identify. So I'm going to go ahead and jump right in by reading these directions that you guys see up here. This tells us to graph the image of a figure using the transformation given. And as you can see, the first four transformations we got are translations, which gives us a good amount of practice here before we move on to dilations. So looking at this, question number one asks us to translate the figure Hij 1 unit to the left and 5 units down. Now, once we do that, we're going to call it something else, not Hij, but instead Hij prime to denote it as the ending image instead of the starting image that we already can currently see. So let's go ahead and start that. And like I said, a translation is a slide of a geometric figure from one place to the next. So we just need to follow the directions that we're given. It's kind of like following a map, okay? So let's start with H and move it 1 unit to the left and 5 units down. 1, 2, 3, 4, 5. Putting our new point for H, which we are going to call H prime. You see that little apostrophe that I put right above that H? That means H prime. And that's our new point for H since we moved it from where it currently was. Now, doing the same thing with the other 2 points. Okay, 1 to the left and 1, 2, 3, 4, 5 down gives us our I prime. And then same thing with J. 1 to the left and 1, 2, 3, 4, 5 down, giving us our new J prime. All right. So now that we have HJI prime, we can go ahead and connect the dots to create our figure. All right. And as you guys can see, I'm being very resourceful. I'm using a piece of paper as my straight edge today that I folded about 4 or 5 times because I ended up leaving my straight edge at school. Now, some of these lines are on a freehand. They're not going to be perfect, but hey, it's okay. We're creating geometric figures, and we can see that this is still, even though one line is a little messed up, a triangle. Okay, and that triangle is Hij prime. All right, so hopefully you were able to see that tutorial. If not, let's go ahead and go over question number 2 here really quick, and then I'm going to give you an opportunity to work through questions 3 and 4 before I work through 3 and 4. All right, so question number 2 asks us to translate triangle GHI 1 unit to the right and 4 units down. All right, so we're doing the same thing that we did in question number 1, but instead of going 1 unit to the left, we're going 1 unit to the right and then 4 units down. All right, so G 1 unit to the right and 1, 2, 3, 4 units down. Now we have G prime. Then we're doing the same thing with H, 1 to the right and 1, 2, 3, 4 down, giving us H prime. And then last but not least, I, 1 to the right and 1, 2, 3, 4 down. And now we have I prime. All right. So with those 3 points being relocated, let's go ahead and connect the dots here to create our image. Got one line there, we got another line right here, and then the last line we got is going right there. Perfect. All right, so that is GHI prime. All right. So if you have any questions, you might want to take some time right now to raise your hand or ask a friend. Either way, okay, get those questions answered. But let's go ahead and move on to questions 3 and 4, which, like I said, I want you to go ahead and right now pause the video and try questions 3 and 4 on your own. I just want to make sure that whatever you were thinking as a thought process to these transformations is actually correct thought processes, and if not, we can go ahead and correct those thought processes and then get to the core of this lesson. So go ahead and pause the video now and try questions 3 and 4, and then start the video back up and make sure that your work matches the work from the notes. All right. So hopefully you pause the video and you have questions 3 and 4 translated. All right. Let's go ahead and translate 3 and 4 together and then make sure that our work matches. All right. So we have a sorry, not a quadratic, but we have a four-sided figure here. Now with this four-sided figure, we're now having to move 4 points, which isn't tougher. It just means we got to move one extra point, and we're just going to move those 4 points 2 units to the left based off of the translation given. So let's go ahead and start with D. Okay, and we're moving D 1, 2 to the left. We're gonna move on from that. Okay, remember we got that as D prime. We're doing that with E as well. 1, 2, and that gives us E prime. Doing it with F. 1, 2, and that's giving us F prime. We're also doing that with the last point G, 1, 2, and that's going to give us G prime. Now, like I said, I'm going to freehand some of these lines here, like the one between D prime and G prime, and the one between E prime and F prime. Now, I'm going to connect my dots here long ways to create my new four-sided figure. Okay, which those two quadrilaterals look the same. Okay, so we know we performed that translation correctly. Now let's move on to question number 4. Question number 4 tells us to move the triangle RQS 3 units to the left and 1 unit up, which seems very simple. So let's go ahead and make sure that we're doing this one correct as well. We're starting with R, 1, 2, 3 units to the left and 1 unit up, and that's going to give us R prime. We're doing the same thing with Q, 1, 2, 3 units to the left and 1 unit up, and that gives us Q prime. And then last but not least, S, 1, 2, 3 units to the left and 1 unit up, and there is S prime. All right, so I'm going to freehand the line between R prime and Q prime, and then let's go ahead and connect the dots between both of those prime points and S prime. There's 1 and 2. Perfect. All right, so we made it through the first 4 examples of geometric transformations. Hopefully, there is no confusion out there, but if there is, okay, go ahead and pause the video now, raise your hand, or ask a partner, somebody around you, for a little help in some misconceptions that you might have. All right, so if you don't have any questions, let's move on to questions number 5 and 6, which asks us to write a rule to describe each translation or transformation. I'm gonna slide my camera down a little bit. I'm seeing we're running out of a little room, but there we go. All right. So we're writing a rule for each transformation that we see, which, based off of the orientation of 5 and 6 being the same, we can assume that these are both going to be slides, okay, translations. The figures aren't getting bigger or smaller as they go from their original point to their prime point. So that kind of is a telltale that this is going to be a translational rule that we're writing here. And we can write it the same ways that they wrote the rules above, which 1 unit to the left, 5 units down, whatever's going on in these questions. All right, so I want you to go ahead and pause the video and try to write the rule for questions 5 and 6 before we come back together and do these two together, and make sure that you correctly describe the movements that you got going on and how many times you are moving in a certain direction. All right, so go ahead and pause the video now and try questions 5 and 6. All right, so let's go ahead and jump into question number 5, which hopefully you started out with your beginning image, which are not prime points. Okay, so we got D, E, and F here, and we're going from D, E, and F to D, E, F prime. Now, the beauty about writing a geometric rule or a transformation rule is in a translation, you only have to identify the rule once because the rule is going to be consistent across all points. So let's go ahead and identify the rule with D to D prime, okay? So we can see here from D to D prime, we have to move to the right 1, 2, 3, 4, 5, 6 units. So we got 6 units to the right. Let's go ahead and write that down before we forget it. Okay, 6 units right. And then from those 6 units right, we need to go up 1, 2, 3 units. All right, so we got 3 units up. And that's the rule that we have for question number 5. 6 units right, 3 units up. And then we can check that rule with E and E prime just to make sure it works. Okay, so if we go from E to E prime, 1, 2, 3, 4, 5, 6, that's correct. And then 1, 2, 3 up, that works. All right. So that's question number 5. Let's go ahead and move on to question number 6. And remember, we're going from our non-prime points to our prime points. So let's go ahead and identify our rule with J. All right, so we're going from J to J prime, and it looks like we have to go to the left 1, 2, 3, 4 units. So let's go ahead and write that down. 4 units left, and then we have to go down 1 unit. All right, so 1 unit down. Looks good, ladies and gentlemen. All right, so like I said, once again, if you have any questions, please raise your hand. Get the help that you deserve. But if there are no questions out there, let's go ahead and move on to the back side, which we're going to identify a couple of more rules. And then after we describe those rules, we're going to jump into those dilations. All right, so going back here. Now we are on questions 7 and 8, still describing rules of our geometric transformations, which once again, 7 and 8, you can see the figure's orientation is the same. The size of the figure is the same. It just looks like it's sliding one direction or multiple directions. So this is definitely going to be a translation that we're describing in questions 7 and 8. So go ahead and pause the video, give question 7A a try, and then start the video back up when you're ready to go. All right, so remember, once again, going from our non-prime points to our prime points, okay? If you go backwards, then you're going to have an incorrect description of your rule. So non-prime to prime, okay? Primary, secondary points, okay? So let's use G in order to identify this transformation. Looks like we need to go up 1, 2, 3, 4, 5, 6 units. So 6 units up. We're not moving to the left or right any, so that's a pretty easy transformation to describe. 6 units up. And we're done with that one. That looks really good. All right. Now let's go on to question number 8. Okay, starting with the non-primes, and this one's a little harder to tell, but with F, you can see that that's a prime point there. All right, but with E's prime point is kind of covered, and so is D's prime point. It's kind of covered. So F is the only one we can really tell that it's a prime. So let's use F in this case in order to identify this geometric transformation, or what we know to be a translation. All right, so we're going from F to F prime when we need to go to the left 1 unit. So let's go ahead and write that down. 1 unit left. And then it looks like we need to go up 1, 2, 3 units. So 3 units up. All right. Perfect. That looks really good. So if you have any questions on translations or how to identify a translational rule, please raise your hand, ask a question, ask somebody around you, get the help that you deserve. All right. So now the big weight that you guys wanted, here it is: dilation, growth or shrink. Now, growth and shrink or a dilation is a little harder to perform than a translation, because in a dilation, we're not sliding. We're either trying to expand or compress the figure based off of the dilation given. Now, I can tell you this: if the dilation is greater than 1, our dilation is going to grow our figure. Okay. If the dilation is in between 0 and 1, then in that case, our dilation is going to shrink our figure. So as you can see in question number 9, we have a dilation of 2 by the origin. And then in question number 10, we have a dilation of 0.5 by the origin. So in this case, we can see that 9 is going to grow GHF, and then 10 is going to shrink RQS. All right, so let's go ahead and start up by performing these dilations. Now, in order to perform these dilations, understand that you're going to double, in this case for question number 9, each coordinate based off of where they are. Okay, so that's what that 2 or the dilation of 2 is telling us. It's telling us to double the coordinates of each ordered pair. All right, so as we can see, G has an ordered pair of -2, +2. So if we double those, okay, based off of what we have, -2, +2. If we double those two coordinates, that's going to give us -4 and +4, right? So let's go ahead and graph that new point, -4, +4, to identify G prime. All right, so we're moving to the left, 1, 2, 3, 4, and up, 1, 2, 3, 4, and that's going to create G prime right up there. Okay, we're doing the same thing with F and H. Okay, so H is located to the right 2 and down 1, so that's going to be the ordered pair, 2 and -1. And remember, we're doubling each of those coordinates. Okay, so 2 doubled is going to be 4, and -1 doubled is going to be -2. All right, so let's go ahead and graph that new point for H prime. We're moving to the left, or to the right, sorry. 1, 2, 3, 4, and down 1, 2, putting our new point for H prime right there. Okay. And then last but not least, F, which is located to the left of the origin, 1, 2, and down 1. It's in the third quadrant, so we know both those coordinates are going to be negative. So we have -2 and -1 there. Double both of those coordinates. -2 doubled is -4, and -1 doubled is going to be -2. So we're going to the left from the origin, 1, 2, 3, 4 units, and down 1, 2 units to get F prime. All right. So now that we have all 4 of our points dilated, let's go ahead and connect the dots and make sure our figure looks like the beginning figure, or our primary figure, doubled. All right. So we should see some growth here. Should have gotten bigger. All right. So connecting the dots here, making sure everything's lined up. It's looking good so far. One more right up to the top, and boom, there we go. All right, so we got our figure now. I kind of drew line GH prime a little close, as you can see, but based off of the ruler that you're using, or the straight edge that you're using, you might have a little more of a gap between GH prime and GH, but that's okay. I'll let that slide today. Okay, I'll turn off my perfectionist today just for that reason. All right, and then moving on to question number 10. Okay, remember, since our dilation is in between 0 and 1, we should see a shrink here based off of what we have as a scale factor. And we'll jump into a little more about that word later, scale factor, or that phrase. Okay, so same thing, taking half of what we currently have now in order to create what we need. All right, so we're looking at triangle RQS. All right, start with R. R is to the left 2 units and up 2 units. So left 2 giving us -2, and then up 2 is +2. Now we're taking half of these two coordinates. So half of -2 is going to be -1, and half of +2 is going to be +1. So from the origin, we're moving to the left one and up one in order to create our prime. All right, and we're doing the same thing with Q and S. Q is to the right 2 units. So it has no y coordinate, or the y coordinate in this case is going to be 0. So we got 2, 0, and we all know half of 0 is still 0, so we're not going up or down any, but we are going to scooch in 1 unit because half of 2 is 1, which puts us right here for Q prime. All right, and then last but not least, S, which is located to the left 1, 2 units, and down 1, 2 units. So it's in the third quadrant. That's going to be a double negative, -2, -2. Half of -2 is going to be -1. So our coordinates are going to be -1, -1 in order to graph S prime. So we're going to the left 1 and down 1. And there we have it. S prime is now graphed. Let's go ahead and connect the dots to see if our figure is half the size of what it originally was. We can kind of see that based off of S prime to R prime, and then comparing that to S to R. Okay, so we can see that SR is double the size. I'm gonna freehand that one, save us some time. So we can see that S to R prime is 2 units, and R to S is 4 units. So we shrunk that to half of what it was. All right. So that is pretty much in a nutshell dilations and translations. So you guys did awesome. Thank you for joining us today. For the rest of what you see on the notes, which are the simplifying the expressions, I want you to go ahead and work with someone in order to get through those simplifications. And when I ask you to work with someone, I'm asking you to work through the problems together and bounce ideas off of one another on what you think you should do in order to achieve the simplest form of each of these expressions, which we know we're not trying to solve for any variables because there are no equal signs in any of these expressions. Those would be called equations. So with that, okay, thank you guys for joining us today. Hopefully you're having a great day. And if not, okay, we got some motivations that we're going to be talking about at the end of our class period today. So appreciate you guys. Have a great rest of your day. See y'all tomorrow. Peace out.